awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Hai, Assalamualaikum. Jom kita revise sambil berehat. Sambil berehat pun, kita boleh belajar tahu dengan tengok handphone. Apa tunggu lagi? Jom kita mula. Assalamualaikum and hi everyone, welcome back to my channel. Jadi pada video kali ini kita nak discuss 6 soalan berkaitan dengan subtopik 2.2 and 2.3 from chapter 2. Jadi apa tunggu lagi? Jom kita mula. Alright, so let's start with question number 1. So here we have a car is moving with constant speed of 80 km per hour. Make sure you change to meter per second first. When suddenly the driver sees a cat 50 meters straight ahead of the car. The driver's reaction time is given 0.5 seconds and the maximum deceleration of the car is 10 meter per second squared. Okay, so let's sketch first diagram that refer to this example. Okay, so for example, we have a car on the road here. Okay, so let's say this is the car. Okay, so initially the car is moving in this direction. Let's say U is equal to 80 km per hour. So let's change to meter per second. And suddenly the driver sees a cat 50 meter away, okay, from the car. So let's say this is the cat. Sorry for the bad drawing. Okay, yeah. Okay, so this is the cat where the distance from the car and the cat is 50 meter. Okay, so let's say this is 50 meter. And then when the driver sees a cat 50 meter away, so he took 0.5 seconds for his reaction. So means that dia nampak cat tu, dia belum lagi tekan brake and he took 0.5 seconds. So means from here, let's say we label as point A, alright, to point B. So let's say this is the reaction time, which is 0.5 seconds from A to B. And then at point B, alright, at point B here, the driver applied the brake. Okay, so brake is applied. Okay, at point B. And after that, what happened to the car? The car will decelerate, okay, at a constant deceleration of negative 10 meter per second squared. So negative means that the car is decelerating. Okay, and remember, so since the car is moving with constant speed from A to B, means that before, okay, the brake is applied, means that VB is equal to 80 km per hour. So now I want to change first 80 km per hour to meter per second. So kilometer dekat atas, kilometer dekat bawah. We want to change to meter. So 1 kilometer is 1000 meter. Okay, and 1 hour. So another one at the top of the fraction. And this is seconds. So 1 hour, 3600 seconds. Okay, so now press your calculator. So 22.22 meter per second. So means that at VB, it's also 22.22 meter per second. Same goes to at point A, 22.22 meter per second. Means that the velocity of the car from A to B is 22.22 meter per second, since the question state that it moving with constant speed of 80 km per hour. Okay, so now for question A, alright, so calculate the total distance traveled by the car from the moment the driver sees the cat until it stops. So we want to calculate the total distance, means that from A to B and then to certain position. Kita tak tahu certain position dia maybe dekat sini, dekat point C dia berhenti, ke dia berhenti dekat sini, dah langgar dah cat tu. So we consider somewhere on the line as point C. So we put VC equal to 0 meter per second. Means that the car will stop at point C. Okay, kalau dia berhenti dekat sini, sinilah yang akan kosong nanti. Boleh? Okay, so now back to question A. So let's write the solution here. Okay, so first we want to calculate what is the distance travel from A to B dalam masa reaction time 0.5 seconds. So I want to calculate first what is SAB daripada A to point B. Okay, so we know that from point A to point B, so UA, initial velocity at point A, is 22.22 meter per second. And since the car is moving with constant speed, so from A to B, the acceleration is 0 meter per second squared. Okay, because constant speed. And the time taken from A to B for the reaction time of the driver, so 0.5 seconds. Alright, therefore, we can write that in order to calculate SAB, so we can write SAB equal to UA, initial velocity at point AT, plus half AT squared. Okay, so we want to find SAB. So A is equal to 0. So UA is 22.22 meter per second and time is 0.5 seconds. Therefore, SAB is 11.11 meter. Okay, so itu baru A to B yang color biru ini. So saya highlight color biru from A to B. And from B to point C, di mana dekat C kita tahu dia akan berhenti. So kita kena kira satu lagi. Okay, so let's write here. Okay, so from B to C, so SBC, which is from B to C, we know already that at point B, the velocity is still 22.22 meter per second. And the acceleration from B to C is negative. Jangan lupa negative sign. Okay. And at point C, kita tahu soalan kata until the car stop. Okay. Until the car stop. So 0 meter per second. Okay. Therefore, based on this information given, we can calculate what is SBC by using equation VC squared. Okay, kita dah tahu VC adalah 0 and UB squared plus 2AS. S tu daripada mana ke mana? Daripada B to C. Okay, for the whole journey. So, final 0, UB is 22.22 squared plus, therefore, SBC is equal to 24.69 meter. Alright. So, 24.69 meter is from B to C. Yang saya highlight dengan color kuning ini. Okay. So, kita total up dulu. What is the total distance? Adakah dia langgar cat ini? What happens to the cat? Okay. So, therefore, we can write total distance. Okay, total distance travel by the car from the moment. Ni awak tulislah. From the moment the driver sees the cat, we can write as S total equal to SAB plus SBC. Okay, so we substitute 11.11 plus 24.69. So S total is equal to 35.80 meter. Okay, so this is the answer. Okay, and 35.80 meter belum lagi melebihi 50 meter. Maknanya kereta itu berhenti sebelum langgar kucing tersebut. So, what happens to the cat? So, kita boleh cakap lah. Okay, the cat is safe. Okay, tulislah. The cat is safe. Okay, so finish part A. Alright, so part B, so sketch acceleration against time graph to show the motion of the car. Okay, so we want to sketch AT graph. Okay, so kita lukis di sini. So we have y-axis, and then we have another one, x-axis. Okay, so now acceleration here, okay, so now let's label A, the unit is meter per second squared, and then T is in seconds, so here is 0. Okay, so we have deceleration of negative 10 meter per second. So bila sketch graph, mesti letak dia punya time frame dia from 0 to, so reaction time tadi kita tahu. Reaction time here 0.5 seconds, and then from B to C, A ke B 0.5 seconds. So what is the time taken from B to C? So we can calculate by using equation of VC equal to UB plus AT. So since at point C, the car will stop, and UB is 22.22 meter per second, plus A is negative 10 T. Okay, so now let's write T is equal to 2.22 second. Okay, ini adalah masa daripada B to C. Alright, kita tahu from A to B is 0.5 seconds. The reaction time from B until it stop, so need another 2.22 seconds. Okay, so bila kita sketch on the graph, so make sure 0.5 tak boleh lah dekat sini 2.22, so dia mesti tambah lah. Okay, dekat this point, saya highlight warna hijau ni, so at this point it should be T dia adalah 2.22 yang kita dah kira tadi, plus 0.5, and it should be 2.72. Okay, so now we can sketch the graph from 0 to 0.5 second. The object is moving with constant speed, means that the acceleration is equal to 0. So saya letak highlight warna merah ni kan. Okay, and then from 0.5 seconds to 2.72 seconds, decelerating at negative 10 meter per second squared. Okay, meter per second squared. Okay, so buatlah line cantik-cantik. Okay, straight line lah. Okay, so finish example number 1. So let's proceed to example number 2. Okay, now question number 2. So here we have Z is playing a ball, alright, on top of a building, but the ball fell. Okay, so the ball fell means that bola itu terjatuh, so U should be considered as 0 meter per second. Okay, sama case macam bola itu drop from certain height. Okay, and hit the ground after 2.6 seconds. So the ball hit the ground after 2.6 seconds. What is the final velocity of the ball just before it hits the ground? And how high is the building? Okay, so kalau kita sketch, so let's try to sketch the problem. Okay, so this one. Okay, so let's say, so we have a building here. Okay, alright, and then, so now let's try to label, means that the object dropped from here. Okay, so we consider this as the initial point. Okay, so this is initial point, and we don't know what is the height of the building, so I put as H. So the object will move downward. Okay, so at this point we want to calculate what is the velocity. Okay, so let's try to solve. So we start with the first one. We want to calculate what is the final velocity, Vy. So as we know, given that U is equal to 0 meter per second and the time taken to hit the ground is 2.6 seconds, therefore we will use formula Vy since this motion is vertically downward. So ni adalah free fall motion. So I will write Uy minus Gt. Therefore Uy is equal to 0. So Uy equal to 0 since the object dropped or the ball fell and hit the ground kan. So Vy, so 0 minus 9.81, T is 2.6 seconds. So jawapannya adalah negative 25.51 meter per second. Okay, So this negative sign means that the direction of the final velocity is downward. So betul lah. Okay, bola itu bergerak ke bawah, so the direction should be downward. Okay, so the magnitude is 25.51 meter per second, but the direction is downward. Okay, so you can write lah. So the magnitude, okay, of final velocity, okay, so you can write as 25.51 meter per second, and the direction, okay, so the direction is downward. Okay, so now how high is the building? So we want to calculate the height of the building. So we need to calculate what is the total vertical displacement traveled by the ball, which is SY. Okay, so kita dah ada VY, kita dah ada UI. Okay, so kita boleh gunalah. Sebenarnya you nak guna formula ini pun boleh, since we have time already, 2.6 second. Kan kata nak guna formula this one, SY equal to UIT minus half GT squared, atau you want to use this equation, VY squared equal to UY squared minus 2G SY. Okay, so mana-mana pun boleh sebab dah ada T, dah ada SY, okay, dah ada VY. So kalau saya guna formula yang kedua ini lebih mudah lah. Okay, tak ada berkaitan dengan fraction. So saya masukkan saja negative 25.51 squared equal to 0 minus 2, 9.81 SY. Daripada initial point to ending point lah kan. Okay, and then SY berapa? Tekan calculator betul-betul. So the answer should be negative 33.2 meter. Okay, kat sini kenapa negative? Because SY is the total displacement traveled by the ball. But since the question asks you to find the height of the building, therefore the height of the building should be equal to positive 33.2 meter. Ketinggian dia kan. So dia tanya ketinggian bangunan. Tapi kalau soalan tanya the total displacement traveled by the ball, so the answer must include the negative sign because displacement is a vector quantity, mesti ada direction. Boleh? Okay, so finish example number 2. Let's proceed to example number 3. Alright, now example number 3. Here we have a stone is projected from the ground with an initial speed of 42. So now let's try to label first, which is U here. So given that U is equal to 42 meter per second at angle of 60 degree, so here is 60 degree above the horizontal. The stone strikes at point A, so here we have point A, okay, and the stone strikes at point A 5.5 second after launching. Okay, maknanya masa yang diambil daripada initial point O, okay, to A is 5.5 second. This is the time taken for the whole journey OA. Okay, so apa yang saya nak buat sekarang? Okay, kita nak cari A, the height of the cliff. Okay, we want to calculate the height of the cliff H, small h. But before we start, I want to put this line. Okay, kita nak kira height of the cliff. So saya akan lukis satu line. Lukis betul-betul Okay, yang sama tinggi dengan height of the cliff. So I want to label this point. Okay, contohlah saya letak ini adalah point K and the maximum height here as L. And here should be A lah. Dia dah labelkan A. Okay, so bila saya label, so mudah untuk saya kira total displacement travel by the stone. Okay, so kita nak cari the height of the cliff. So apa yang saya buat, saya hendak tulis. Jadi apa yang saya buat, saya nak tulis let height of the cliff sebagai H. Alright, and then from the top of the cliff, okay, and then from the top of the cliff, okay, and then from the top of the cliff here, okay, yang line saya lukis tadi sampai maximum height dekat point L, saya nak label sebagai apa? Okay, kita boleh label sebagai X. Okay, contohnya. So, this one should be X. Okay, so memudahkan saya. And now, since we already know that T from O to A is equal to 5.5 seconds, therefore, we need to calculate first what is the total displacement from O to L. Okay, so total displacement, okay, from O to A, okay, so saya akan tulis sebagai SY OA equal to SOK, dia akan bergerak daripada O ke K dulu, plus SKL, K to L, and then daripada L ke A. Okay, so now look at here. So we have O to K, the direction is upward, so dia akan jadi positive H. Ketinggian daripada tanah ke point K ataupun top of the cliff yang kita dah lukis line tadi adalah positive H. And from K to L is positive X. Kenapa positif? Sebab arah dia bergerak ke atas. And from L to A, dia turun ke bawah plus negative X. Okay, so dia akan jadi positive H plus positive X plus negative X. So, saya boleh cancel positive X and negative X. So, we can write the total displacement travel in vertical displacement untuk batu tadi adalah positive H. Okay, SY from O to A. Okay, so based on this information, so I want to find the height of the cliff. So, sekarang kita dah dapat dah term H ini, iaitu the height of the cliff. So, by using the time taken to travel from O to A, which is 5.5 seconds, so saya akan tulis formula SY for the whole journey equal to UYT minus half GT squared. Okay, so saya ingatkan bila you tengah buat berkenaan dengan vertical direction ataupun Y component, labelkan sebagai Y. Okay, so now kita ada T, tapi kita lupa lagi untuk kira UY. Okay, kita dah ada T, so UY we can calculate from the diagram here. So resolvekanlah. So kita akan ada UX which is U cos 60, and then kita ada UY which is U sin 60. Okay, so we can substitute in this equation. Masukkanlah, nak kira asing pun boleh. U tadi kan dah dapat kan, U 42 cos 60. So berapa? U 42 cos 60, let's say 25 meter per second. And then U sin 60 you kira so you akan dapat 36.37 meter per second. So let's substitute here. So kita guna yang tebal sikit. Okay, 36.37 T dah ada, 5.5 minus half 9.81 times 5.5 squared. Therefore, SY for the whole journey, you akan dapat 51.7 meter. Okay, so since SY OA, okay, kat sini tadi equal to H, therefore, the height of the cliff is 51.7 meter. Okay, so finish part A. Okay, now B, we want to calculate the speed of the stone just before impact at A. So we want to calculate what is VA. So kalau kita lukis direction of VA, so it should be in this direction. Okay, so VA, and we need to know what is VAX and VAY. Okay, sebab kita nak kira VA, the final velocity at point A, so VX squared plus VY squared, VYA and also VXA. Okay, so kita nak kira, but before that, so saya nak padam dulu yang ini. Okay, so since we want to find what is VXA, so remember for the projectile motion, UX is always equal to VX. Okay, so ingat lagi for projectile motion, for the X component, UX equal to VX. Therefore, VXA kita akan dapatlah equal to UX, di mana UX kita dah kira tadi 21 meter per second. And for VYA, so we need to calculate what is VY at point A by using equation of VYA equal to, okay, kita tulis kat bawah ni, VYA equal to U, okay, uy minus gt. Uy is the initial speed in y component and t is the time taken daripada O to A, 5.5 seconds, right? So let's substitute the value. 36.37 minus 9.81, t is 5.5. Therefore, VYA adalah negative 17.59 meter per second. So betul lah negatif sebab apa? Kalau kita tengok VYA kat sini, so its direction is downward. Okay? Tapi soalan bukan suruh kita cari vertical velocity at point A ataupun dia tanya what is the horizontal velocity at point A. Okay? Tapi soalan tanya the speed of the stone. Speed so dia nak magnitude saja. So maknanya dia nak cari VA, bukan VAX, bukan VAY. So kita akan guna formula inilah. Okay? VA equal to VXA squared plus VYA squared. So we substitute. So VXA 21 squared plus negative 17.59 squared. Don't forget to take the square root. Okay, ini formula dia lah untuk resultant vector untuk V at point A. Therefore, VA is equal to 27.39 meter per second. Okay, sebab soalan suruh kita kira speed, so we just calculate the magnitude, okay, of the speed lah. Okay, speed adalah scalar quantity, so kita hanya kira magnitude saja. Tapi kalau soalan tanya what is the velocity of the stone just before impact at A, velocity. Bila tanya velocity, you need to calculate the direction as well. Okay, so direction theta equal to inverse tangent. Okay, Vy at point A over Vx at point A. So, you kena kira theta. So, substitute all the values. So, you akan dapat 40 degree where the direction, so this is Vxa and this is Vya. Okay, so Va. So, theta here is equal to 40 degree below positive x-axis. Okay, below positive x-axis. Okay, so finish question B and how about question C? Okay, so question C, the maximum height reach above the ground. So, kita ini senang saja kan? So, since we want to calculate the maximum height, so we already know that, okay, at maximum height, Vy is equal to 0. Okay, so we can write at maximum height, Vy is equal to 0. Therefore, we can use equation Vy squared equal to Uy squared minus 2g Sy. Okay, so Sy dekat sini merujuk kepada maximum height. Sebab apa? Kita nak gantikan Vy nanti equal to 0, means that sini adalah maximum height. Okay, so when we substitute the value of 0 here, Uy is 36.37 minus 2, 9.81 and Sy ini saya letak H maximum. Okay, therefore, the maximum height is equal to 67.4 meter. Unit jangan lupa. Okay, so finish example number 3. Let's proceed to example number 4. Okay, example number 4, you kick a soccer ball off from the top of a roof of 10 meter tall building, giving it a velocity of 22 meter per second, means that this is the height of the building, 22 meter per second is the initial velocity at angle of 63 degree above the horizontal. Okay, apa kita buat? Kita mesti lukis dulu. Okay, let's say this is the ground. Okay, and then this is the building. Okay, alright. Saya adjust kejap. Okay, and then so you kick the ball. Okay, so let's draw here. So this is the initial point. So I want to label this as the initial point. Okay. Allah. Tak lurus saya lukis. Okay, awak lukis lurus pakai pembaris. Okay. So the ball, you kick the ball. So you kick the ball at angle of 63 degree. Okay, and this is the initial U. So given that U is equal to 22 meter per second. And what happened? Okay, so this is the path of the ball moving upward, reach the maximum height, lepas tu dia turun ke bawah. Okay, sorry, saya adjust sikit. Okay, contohlah dia pun jatuh kat sini. Okay, landing at this point with a velocity V. So, kena ada Vx. Okay, so Vy. So, now here is the maximum height. Okay. So, from the initial point to the maximum height, so ini adalah saya letak sebagai H. Okay. From initial point to here is the maximum height. Tapi kalau kira maximum height from the ground, you kena tambah the height of the building. Okay. The height of the building. Tengok bila soalan tanya what is the maximum height reached by the ball, mesti tambah dengan the height of the building. Okay. Sekarang kita label ini as 10 meter. Okay. And then let's try to resolve first. Ux and Uy. Ux ke kanan. Uy is upward. Okay. So Ux should be 22 cos 63. And it will give you 10 meter per second. Check tekan calculator. Practice tekan calculator. This one 22 sin 63 and it's equal to 19.6 meter per second. Okay. So how much time is the ball in the air for? Berapa lama masa bola itu berada pada udara sebelum dia jatuh ke tanah? Okay. So saya macam biasa saya suka labelkan point. Okay. So I will label this point as O, which is starting, and this is A. Dia akan pergi ke B, back to initial point, and then dia akan move downward to the ground C. Okay, point C. Okay, so jom kita kira. A, we want to kira total displacement. Kenapa saya nak kira dulu total displacement travel by the ball? Sebab kita nak cari total time dia bergerak daripada point O to point C. Boleh? So, saya nak kira dulu total. Okay, displacement travel. Okay, by the ball. So, saya akan letak SY. So, maknanya dia daripada O pergi ke A, reach the maximum height. Plus from A pergi ke B, plus from B to C. Okay. Now, look at this diagram. Okay. Sekejap ya. Okay, so saya highlightkan dulu. So now from O to A, so positive H bergerak ke atas. From A to B, negative H. From B to C, SY dia adalah negative 10. Okay, negative 10 because the direction is downward. Okay, so bila saya masukkan kat sini, dia akan jadi H, positive H, plus negative H, plus negative 10. Okay, so this one we can cancel. So the total displacement travel by the ball from O to C, okay, from O to C adalah negative 10 meter. Okay, and to find the total time, okay, total time the ball in the air, okay, so we can write, okay, equation kita adalah SY, okay, daripada O ke C lah, UYT minus half GT squared. Okay, so kalau SY itu daripada O to C, maknanya masa yang kita kira ini adalah masa keseluruhan daripada O ke C. Okay, so let's substitute the values. SY is negative 10. Kalau tersilap, tak letak negatif, jawapan terus akan jadi salah. So, UY is 19.60 minus half 9.81 T squared. Therefore, okay, rearrange the equation. Ini jadi quadratic equation. So, saya susun semula. Negative 4.905 T squared plus 19.60, okay, plus 10 equal to 0. Kan quadratic equation. Tekan calculator. Okay, saya tulis kat sebelah ni, tak muat. Okay, therefore T is equal to, you akan dapat dua lah, satu negative value, satu positive value. So let's choose the positive one, which is 4.45 meter. Okay, so this is the answer. Alright, and now question B. How far from the base of the building does the ball land? So how far? Maknanya daripada tempat dia berhenti dekat point C tadi, daripada base of the building, so dia adalah horizontal displacement. Maximum horizontal displacement. Okay, berapa maximum horizontal displacement tu, paling jauh dia boleh pergi. Okay, so dia akan jadi Sx equal to Uxt. Okay, gunakan formula ini. So Ux kita dah tahu berapa nilai dia, which is 10 times T, 4.45. Therefore Sx equal to 44.5 meter. Okay, ni saya tersilap ni unit atas ni, second. 4.45 seconds. Okay, okay, unit kena betul. So ini 44.5 meter. And the last one, how fast is the ball going before it hits the ground? Jadi, how fast? So, inilah kita nak kira V at point C. So, kalau kita tulis formulanya, okay, VC equal to square root VCX squared plus VCY squared. Okay, so always remember that VC is equal to VCX equal to UX. Kita dah tahu nilainya 10 meter per second. Okay, at any point, mesti ingat at any point, UX equal to VX. Okay, so VX dekat point C samalah dengan UX, 10 meter per second. Tapi untuk VYC, kita kena cari dulu. Okay, guna formula ini. Okay, VYC, UY, kita dah tahu berapa, kita kira tadi 19.6 minus 9.81. T kita dah kira dah tadi 4.45. Masa yang diambil daripada O ke C. So VY kita akan dapat negative 24.05 meter per second. So baru dapat VCX dengan VYC. Okay, kita mesti kira VC lah. Substitute in the formula. Okay, masukkan nilai dia. Plus negative 24.05 squared. Okay, so berapa dapat? So the answer should be 26.05 meter per second. Okay, so ini adalah dia punya magnitude of the velocity at point C. Okay, so dia tanya how fast. Okay, dia nak tanya hanya magnitude sahaja. Tapi kalau soalan sebut calculate the velocity at point C, macam biasa, you mesti kira theta equal to inverse tangent Vy over Vx. So, you akan dapat 67.42. Ini in case soalan suruh kira velocity, mesti kira sekali direction. Okay? And this is below positive x-axis. Okay? So, finish question number 4. So, let's proceed to question number 5. Okay, so question number 5. So, let's read the question first. We have an aeroplane flying 490 meter above the ground level at 100 meter per second. Release a block. Okay, so ini cerita pasal object projected horizontally. Okay, so tak ada apa-apa angle. So means that kita ada, sekejap So means that kita ada aeroplane. Ni. Okay, aeroplane. And it's moving in this direction. Okay, U 100 meter per second. And at the same time, dia akan release a block. Okay. So, maknanya U ini pun sama lah. UX sahaja. Okay. So, UY equal to 0. So, this question is about object and object projected horizontally. Okay. So, given that the height of the aeroplane is 490 meter from the ground. Okay. So, the path of the object should be start from here, so dia akan travel turun ke bawah macam ini. Okay, so this is the final point. So this is the final velocity V. So at this point you need to calculate. Okay, Vx always equal to Ux, and Vy you kena kira. Okay, so soalannya, how long it will take to touch the ground? Berapa lama masa diambil untuk sampai ke untuk cecah sampai ke tanah tu kan? Okay, so kita nak guna formula apa? Okay, so for question A, I will use formula from Y component. Alright, so Sy, okay, since kita tahu nilai ini adalah nilai Sy, tapi nanti mesti negatif. Kenapa? Sebab objek bergerak ke bawah. Okay, so Uy saya dah tahu 0. Okay, so kita boleh masuk saja dalam formula ini. So here negative 490. So Uy 0, so sini semua 0 lah. Minus half 9.81 T squared. Okay, we can cancel the negative sign. Therefore, T you akan dapat 9.99 second. Okay. And B, how far on the ground it will strike. Okay, maknanya daripada tempat dia tadi, okay, daripada tempat mana aeroplane tu berada sampai kat mana dia berhenti, dia touch the ground. So how far, sejauh mana, okay, dia boleh pergi. So kita nak kira Sx. Okay, so this is very simple. So Ux kita dah tahu 100, T is 9.99, therefore Sx equal to 999 meter. Okay, so finish example number 5. Okay, example number 6, the last one. We have a student throws a book horizontally. So here means that the object is projected horizontally. Okay, so the initial speed is given 12.5 meter per second. The book lands on the ground 31.8 meter from the base of the building. How high is the window about the ground? So, berapa tinggi tingkap daripada tanah kan, from the ground. So, kenapa highlighter pula ni? Okay, kita ambil yang inilah. Sana. Okay, macam ini. Okay, so let's proceed. Contohlah ini rumah dia. Okay, kita lukis sikit. Ni rumah dia. Okay. And then tingkap dekat mana? Okay, contohlah tingkap dekat sini. Okay. So this is the window. Okay. So saya warna merah ni adalah buku dia lah. Projected horizontally. So Ux dia adalah 12 meter per second. Sorry, 12.5. Okay. And the book will land on the ground after certain time. Okay. So saya tak tahu berapa. So this one should be Vx and this is Vy. Okay, bila dia touch the ground. And then the book lands on the ground 31.8 meter from the base. So given that this is the base, okay, daripada base of the building 31.8 meter. So ini adalah dia punya nilai Sx, maximum horizontal displacement. Okay, so sekarang kita nak kira Sy. Okay, kita nak kira ini. Okay, berapa ketinggian window tu daripada tanah. Okay, so maklumat kita ada Ux, and remember Uy kita pun ada 0 meter per second. So in order to calculate the time taken, okay, kalau kita nak kira dia punya Sy, kita perlu cari dia punya time. Okay, this one 0 since Uy equal to 0. Tapi sekarang saya ada masalah, saya tak ada time. So in order to find what is the time taken for the book to touch the ground, so let's use equation from the x component, which is Sx kita dah tahu, kita gunakan maklumat yang ada untuk cari time. Okay, therefore T is equal to Sx over Ux. So let's substitute all the values. Sx dia dah bagi. Okay, sorry, itu adalah Ux kan? Jangan terbalik okay, 31.8. UX is 12.5. Okay, so 31.8 divide 12.5, so T you akan dapat 2.54 second. So sekarang kita dah ada time, kita boleh substitute kat sini. Okay, so SY equal to negative half 9.81 T squared. T kita tadi dah kira 2.54. Okay, masa dia touch the ground 2.54 seconds. Therefore, you akan dapat nilai SY negative 31.65 meter. Betul lah negatif. Kenapa? Sebab objek itu bergerak ke bawah. The direction of the displacement SY negative 31.65. Okay, vertical displacement dia negative because the direction is downward. Okay, tapi soalan bukan tanya vertical displacement. Soalan tanya berapa tinggi window daripada ground. So, therefore, kita bolehlah tulis balik the height of the window. Okay, from the ground is equal to 31.65 meter. Ketinggian dia positif lah. Okay, so finish all examples. Alright, so thank you for your support. So please like and share this video kepada kawan-kawan anda jika anda rasa video-video saya bermanfaat dan boleh membantu semua. So semoga kita jumpa lagi dalam video yang seterusnya. Okay, Assalamualaikum dan selamat sejahtera. Jumpa lagi.